The World Series is a championship between the National and American Leagues in baseball. The champion is the first to win 4 games, so it's best 4 out of 7. Sometimes it goes all 7 games, quite often actually, which makes you wonder about things, but it doesn't always go all 7 games. It could finish in 4 games. If the National League team wins the first 4 games, the series is over. If 2 teams are evenly matched, and that's a big if, but if they were evenly matched, the probability of the series ending in 4 games is 1/8. It makes sense that it would be a low probability because you wouldn't expect one team to just sweep if they were evenly matched. But I feel like it should be 1/16th, but I think they're basing this on historic trends and historic data where the teams were considered closely matched. The probability of the series ending in 5 games is 1/4, ending in 6 games is 5/16, and ending in 7 games is also 5/16. Now, I immediately would like to know if those add up to 1, because there are only 4 possible outcomes. Either someone sweeps and goes like straight through without a loss, or the most. So the 4 games is the least possible. 7 games is the most, because if it goes 7, it could only be like a 3-3 tie, and then it's decided in the 7th game. So these should add up to a probability of 1. And if I think about a common denominator of 16, this is 2/16, this is 4/16. So 2 plus 4 is 6, plus 5 and 5 is 10 more, 6 and 10 is 16, 16, 16. Okay, so I don't know about you, but in situations like that, I like to see if the problem even adds up the way it should. The expected number of games based on these different probabilities is another expected value. So you see how expected value could be used in so many different types of scenarios. The value here would be 4 games. The probability that it ends in 4 games is 1/8. So 4 multiplied by 1/8 plus it could end in 5 games, but the probability of that happening is 1/4. It's much more likely to end in 6 games, and equally likely as ending in 6 games to end in 7 games. And so we can get an average number of games that we expect it to end in based on these products. This is 4/8. I'm going to do it fraction form. 5/4, 30/16, and 35/16. I'm going to keep it fractions so that I can just get a common denominator of 16, 8/16, and 20/16, and 30/16, and 35/16, for a total of 93/16. I know 4/16 is 64, 5/16 is 80, 6/16 would be 96, so it's not that many. It's 5 and 13/16. Or if you did it as a decimal, if you used a calculator and did or divided and did it as a decimal, 5.8125. This is the average number of games. Like, you would expect it to be much closer to a 6-game series than a 5-game series most of the time. That's probably pretty accurate, because it seems like it goes to 7 quite often. Probably ends in 6 a lot. Very rarely someone sweeps, and very rarely someone goes with only 1 loss. So this is the expected value.